Hello, I'm Christothea Herodotou. I'm an associate professor at the Open University in England, and this talk is about science capital and why it is important. So what is capital? The origins of the concept of capital goes back to sociology and the work of Bourdieu back in 1986. By capital, we refer to the sum of a person's assets in use. And by assets, I refer to things like the financial situation of a person, culture, social position, and symbols of status. So Bourdieu talked about different forms of capital in the sense of symbolic capital, referring to things like prestige, cultural capital, referring to a person's qualifications and competences, social capital, referring to how recognized a person is by others, and economic capital, referring to financial means. For Bourdieu, we inherit our cultural attitudes during childhood from our previous generations. Also, he thought that income is an important factor that shapes our tastes and preferences. So how did we move from capital to science capital? What has been observed is that young people find science as an interesting topic. They also have very positive views of scientists and their work. And their parents think that science is an important topic. Yet a paradox has been observed. Their intention to become a scientist when they grow up was found to be very limited. So the STEM skills gap was observed. This gap refers to careers in science, technology, engineering, and maths, and the fact that for the last 20 years we have the same people occupying this kind of jobs, the same gender, mostly male, the same social status. And therefore, this raised issues as to why this is happening. Researchers, in particular Archer and her group, introduced the concept of science capital, which is based on those ideas of Bourdieu about social capital. So science capital is something that explains why only some young people take part and pursue a career in STEM. It explains why science is not for some people, so why some young people say that science is not for me. What is science capital? As you see on this picture, is like a bag that contains different things related to science. These things are science-related knowledge, science-related attitudes, experiences, and resources that someone acquires throughout life. So it's about what you know in relation to science, how you think about science, what are your attitudes and beliefs, what do you do that relates to science, and who you know that maybe has a science career. So Archer and her group developed a 14-item scale capturing 8 dimensions of science capital. So they defined science capital through those 8 dimensions. Briefly, the first one refers to scientific literacy, and this is about the knowledge and understanding a person has about science and how it works. The second one is about science attitudes, values, and dispositions, and this is about whether young people, they see science as relevant, as being relevant to their own life. The third component is about knowledge with regards to the transferability of science. So whether it can be applied to science qualifications, knowledge, and skills. So do they see, for example, that science can lead to a wide range of jobs, not necessarily science-related ones? The fourth element is science media consumption, and this refers to whether a person watches science-related television, they read science-related books and magazines. The fifth element is whether they take part in out-of-school science learning context. So how often do they visit museums, science exhibitions, science clubs? The sixth element is about the skills, knowledge and qualifications in their family. So whether other people in their family have or are related to science to some extent. The seventh element is knowing people in science-related roles. So whether they have people in their family, friends, peers, or community circles that have science-related jobs. And the very last one aspect is talking about science in everyday life. So it's whether a young person, for example, talks and chooses to talk about science with other people and more likely out of school. So why is this concept important? Here I share a large-scale study from the Enterprising Science National Survey. This survey in this survey, more than 3,500 young people took part, aged 11 to 15 years old. And what the researchers found out was that only 5% have high science capital. And these were more likely to be boys, South Asian, and socially advantaged ones. Then 68 of them had medium levels of science capital. And perhaps most importantly, nearly one third of the participants, 27%, were found to have a low science capital. And this is quite concerning because it means that these people may not have the opportunities to take up or participate in STEM-related activities. Overall, the main conclusion from this study was that the more science capital a young person has, the more likely is to continue with science after the age of 16 and also see themselves as having a science identity. So why does science capital matter? I summarize here the reasons why this concept and this understanding is very important. The first one is that it can help us understand why. First, it helps us understand the science-related background of learners, so we can capture, understand, describe the science background of learners. Secondly, it explains why some learners and not others see STEM as not being for them. They don't want, for example, to have a career in science. Thirdly, it can guide interventions that are needed and could actually increase the science capital of young people, especially those identified as having low science capital. And these kind of interventions are quite significant because they can promote social justice and equity in the society. In particular, it can inform teaching and teaching approaches as to how to support the development of science capital in young people while they are growing up and while they are at school. For example, some interventions could be to introduce scientists to students so they communicate with a real science and they understand how they think and how they became scientists, or possibly connect some of the school activities with out-of-school programs like research projects or citizen science projects. In particular, I want to comment on this intervention a bit more. In particular, I want to say and talk about how science capital could be supported through citizen science activities. By citizen science, I refer to the participation of the general public in research activities in different capacities. It could be to help scientists collect data, to help scientists analyze data, or it could be to conceive, put together, and implement their own piece of research that is relevant to themselves and their communities. So in this slide, I just briefly mention how citizen science is moving towards an understanding of community needs and towards community-led research. So there are different types of citizen science we could use to engage young people with and potentially increase their science capital. Some programs, citizen science programs, take place in the field. Some others are purely online, and some others are have a combination of field-based and online elements. This is what the citizen science looks like in the field. It's all about people getting together with adults, scientists, researchers, observing, taking notes, recording and documenting nature and biodiversity. These kind of events are organized by museums, for example. And here I have the example of the Natural History Museum in London. They organize one-day citizen science programs where they invite people, young people and adults, to discover as many species as possible in a set location, like plants, animals, and fungi available in the location, in a set location. And this normally spans a 24-hour window, and they are called bioblitzes. Now, when these events are longer than a day, they are referring to as ongoing programs. And here I have the example of the City Nature Challenge, managed by two other natural history museums in California. And the last one took place between May the 4th and May the 9th. And the whole idea is that different cities across the world are capturing and documenting biodiversity. The third type of citizen science takes place purely online and is different citizen science platforms that enable people to take part in scientific research. And I have here the example of the iNaturalist, which is more of a social network about biodiversity, the example of Enquiry, which is about scaffolding the process of community-led research, and the example of Zooniverse, where participants mostly help scientists to analyze data. So how does science capital and citizen science relate? What I put on this slide is on the left-hand side the aspects of science capital that could be fostered or for which we have evidence that can be fostered through participation in citizen science programs. So in particular, what we know from research is that people who take part in citizen science have a better understanding of science, they know better how science is done, they have more confidence and performance to take part in scientific activities, they reported changes in their perceptions of science, they developed new roles in practicing science, and also an appreciation of nature. So this evidence from a number of studies point to aspects of science capital like scientific literacy, scientific attitudes and values, participation in out-of-school learning contexts, and knowing people in the practice of citizen science. And here I will mention in particular a project I have been involved with the last 4 years. The aim of it was to understand and improve the design of citizen science programs for young people in particular across 3 natural history museums. You can see here the California Academy of Sciences, the Natural History Museum in London and in Los Angeles. And what we found from this project, actually I would just refer to online participation in citizen science activities, is that the young people aged 5 to 19 years old had an enhanced understanding of how real science works, increased confidence and performance in science. They changed their perceptions and they developed new roles while they took part in these programs. Perhaps an important additional finding was that pre-existing science capital, in particular prior learning, talking about science out of school, visiting science platforms, and physical places such as museums, were related to reported learning outcomes. So the greater the learning outcomes reported from taking part in a citizen science program, the greater the science capital was. So in a way, those people who had significant science capital got the most out of participation in these programs. And of course, this raises questions as to how can we design citizen science programs in ways that develop also the science capital of those young people that is not as developed as the ones we examined in this study. My last few slides is to talk about a tool that we can engage young people with as a means to develop their science capital. And this is the Enquiry Platform designed and managed by the Open University in England. So this is a tool where any person can design a study. There are a number of, there is an authoring functionality that walks them through the process of designing a study. They can test their study and pilot it with people and then improve the design. They can collect data in the form of text, images, sensor-based data. They can visualize data, and by visualizations I mean that they can open the data to participants. They can show them summary graphs while data is collected, or they can see actual responses and they can reply, comment, or like these responses. And of course they can share ongoing and final findings via the platform. We designed this tool in order to help people, especially those with limited, I would say, science capital, to learn about how research is done. And this learning can be achieved by taking part in studies set by others. And when we design studies, we provide feedback always as to so people can actually find out more about the topic they took part in. Also, we provide those data visualizations as a means to engage them with the data as this is collected and through peer learning. Also, they can set up their own studies through the authoring functionality of the tool. It is free to use and it is supported by scientists. So if a group of young people want to set up a study and they don't have the skills to do, they can be supported by the tool, and also scientists that communicate with potential authors and guide them in the process of designing a study. So the whole idea is about helping people to start thinking critically and scientifically. And here I have the example of the Garden Watch, where we ask people to record who lives in their gardens, and we got more than 200,000 responses with support from the BBC. This was my presentation. Thank you for listening, and I look forward to the question and answer session during the symposium. Thank you.